Yes, hello, my dear students of 10th standard. How are you? I hope that you are all fine and safe by the grace of Heavenly Father. Okay, what about your learning process? So, nowadays we are discussing about periodic classification of elements up to extractive metallurgy of copper that we have discussed in the earlier section. So, before going to start the next topic, that is the extractive metallurgy of iron, I would like to ask some questions in this chapter, what you have learned in the earlier session. So you try to give answer. First question: how many elements are in the modern periodic table? How many elements are in the modern periodic table? So you know very well there are 118 elements in the modern periodic table. More or less 94 elements are naturally occurring. Remaining elements are artificially prepared. Then, who prepared the modern periodic table? Henry Moseley prepared the modern periodic table based on a new property of elements called atomic number. And what is called atomic number? Atomic number is the total number of proton present in the nucleus of an atom. Then what is the definition for modern periodic law? The physical and chemical properties of the elements are the periodic functions of their atomic numbers. And what are periods? The horizontal rows are called periods. There are 7 periods in the modern periodic table. And what are groups? The vertical columns in the periodic table starting from top to bottom are called groups. There are 18 groups in the periodic table. Also you have learned about atomic radius, which is further classified into metallic radius and covalent radius, and ionic radii, ionization energy, electron affinity, electronegativity. Then the next topic we have discussed metallurgy. Metallurgy is the science of extracting metal from their ore, and there are steps to concentrate the ore, and some terms in metallurgy: mineral, ore, mining, gangue, flux, slag, smelting. Those things we have discussed. Also, how to separate or concentrate the ore. There are 3-4 methods are given in your book. First one, hydraulic or gravity separation, based on the density difference or specific gravity difference between the ore and gangue. This is normally used to purify oxide ore. Then magnetic separation based on the magnetic property of the elements. This is for the elements having the property of magnetic, like a tin stone. The next method, froth flotation. The basic principle applied in this process is the wettability of the ore with the oil and the gangue particles with the water. So the light weight ore, like sulfide ore, can be concentrated using this method. Next one, chemical method or leaching, that is used to purify, concentrate more or less a pure form of ore. Also we have discussed about the occurrence of ores in Tamil Nadu. Then the properties of metals, their physical state, luxure, hardness, melting point, boiling point, density, ductility, malleable, conduction of heat and electricity, solubility. The chemical properties, they are valence electron. They are going to have 1, 2 or 3 electrons in their outermost shell. Then they discharge at cathode because of their positive nature. Their atomicity is more or less monoatomic in nature. And their oxides of usually basic in nature. And when we discuss the extractive metallurgy of aluminium, we have discussed that aluminium is most abundantly obtained in the earth crust, and it is highly reactive metal, so always obtained in the combined state. So there are three ores: bauxite, cryolite, corundum. Bauxite is the chief ore, and there are two steps involved in the extraction, that is conversion of bauxite into alumina by Bayes process, then electrolytic reduction of alumina by Hall's process. Also, we have discussed about the physical properties of aluminium, chemical properties of aluminium, then uses, then in the extractive metallurgy of copper. Copper was named as cuprum by the Romans, and it is more or less obtained in combined state, in some places in the form of native state. And the copper byrate is the chief ore of copper, and there are a few methods in the extraction of copper from copper byrate. That is, first one, concentration of ore by froth flotation, then roasting to remove the impurities in the form of oxides like sulfur, phosphorus, arsenic and antimony, then smelting, heating with the coke, sand in blast furnace, then bessemerization. Then to get pure copper, electrolytic refining is applied. Also, we have discussed about the physical properties, reddish brown metal, and a reaction with air and moisture, and reaction with the acids, also uses of copper. So my dear students, now we are going to discuss about the extractive metallurgy of iron. So iron is the second most abundant metal. The first most abundant metal is aluminium. Second most abundant metal is iron. So in the form of oxide, sulfide and carbonate. So iron is highly reactive metal. So this is always obtained in the combined form, in the form of oxide or sulfide or carbonate. So there are three important ores of iron: hematite Fe2O3 oxide ore, magnetite Fe3O4, that is also oxide ore, iron pyrite FeS2 iron sulfide, that is sulfide ore. So there are three ores given. Out of these three, the chief and important ore is iron pyrite, that is hematite. Hematite is the important chief ore, not iron pyrite. Hematite, that is Fe2O3, is important chief ore. From this ore only iron is mostly extracted. So first method, concentration by gravity separation. So in the gravity separation method, stream of water. So it is given, see, the powdered ore is washed with the steam, STAM, that is not STAM, STREAM, stream. Stream means a jet of water is allowed. And what happens, see, the light sand particles, impurities are washed away in this process. Heavier ore particles only settle down in the given grooves and cuts. The grooves and cuts, the heavier metallic particles or ore particles are settled, and light impurities are washed away by the jet of water, the stream of water. That is the gravity separation method. Next one, roasting and calcination. So usually roasting is heating the ore in presence of air, in the excess of air, but calcination is The ore is heated, the limited supply or in the absence of air. Reverberatory furnace is used here. In this process, the moisture, because in the previous process we used a jet of water, so automatically the ore is going to be wet. The moisture is removed in this process when we are going to heat the limited supply of air. Moisture is given out and sulfur, arsenic, phosphorus, these impurities are oxidized in the form of sulfur dioxide, arsenic oxide, phosphorus trioxide or pentoxide. So these are removed in the form of oxides. Then next step, that is smelting. Smelting is nothing but this is take place in the blast furnace, that you have seen the diagram here. The blast furnace, it is more or less a cone shaped furnace made up of hot bricks, and the top of the blast furnace is consisting of a cup and cone arrangement, that is called the bell and hooper. Cup and cone arrangement or bell and hooper, a cone shaped device which is used to send the mixture, through in a uniform manner, in a steady manner. So it going to allow the mixture steadily, uniformly, slowly to the chamber. Then at the top right hand side there is a valve to remove the hot gases, and bottom it is given pipe for hot air blast. So how the mixture is going to be heated here, a special type like tire, TUYERE, this is called the hot air blast is allowed to send through tire. It is a type of pipe usually made up of copper, through which hot air is blown into the blast furnace. So hot air is blown into the blast furnace for the chemical reaction. Then at the bottom of the blast furnace, iron to get out to remove the fused iron outlet is given. Above that slag outlet to remove the impurities. These are some of the important parts in this blast furnace. Now see, the charge consisting of roasted ore, coke and limestone. So what is called the charge? Charge is nothing but the mixture which is allowed into the blast furnace. The mixture which is allowed into the blast furnace. So what are the components in the mixture? Three things are given: roasted ore, coke and limestone. Three things you have to note down: roasted ore, coke and limestone. These three are mixed in the ratio of 8:4:1. 8:4:1, and allowed through the cup and cone arrangement, Cooper arrangement, to the blast furnace. And there are three important regions in the furnace. That means in three stages the reactions take place in the blast furnace. In three stages the reactions are taking place. So it is given, see, lower region. Lower region means the blast furnace, the lower portion, the inside. We are talking about the inside lower portion, because the lower portion, the hot air is going to be blown into the blast furnace, so the temperature is going to be high at the bottom of the blast furnace. That is the lower region. That region is also called combustion zone. Combustion means a process of burning. So the temperature is more or less going to be 1500 degrees Celsius in this region. So at this temperature, the coke in the mixture burn in presence of oxygen to form carbon dioxide. So when the coke burn means what? The temperature is further going to increase. When burning process take place, the temperature further increase. So this is a type of exothermic reaction. Exothermic means what? That is the reaction which involves the liberation of heat energy. So carbon plus oxygen at 1500 degrees Celsius, carbon dioxide gas is formed plus heat. The plus heat represent, that is the reaction which involve the liberation of heat. Liberation of heat means heat energy is given out during the chemical reaction. Heat energy is given out during the chemical reaction. So these type of reactions are termed as exothermic reaction. Exothermic reaction. So you have to understand the lower region temperature is 1500 degrees Celsius. Carbon bond with oxygen, carbon dioxide is formed, and exothermic reaction. Then see second portion, that is the middle portion of the blast furnace, that is fusion zone, also called fusion zone. Here the temperature is more or less going to be 1000 degrees Celsius. 1000 degrees Celsius. Here what is take place? See, the carbon dioxide is reduced to carbon monoxide. Reduced. Reduced means what? That is the removal of oxygen. Removal of oxygen. Carbon dioxide to carbon monoxide. So carbon dioxide further react with the carbon, that is the coke, which is allowed in the charge. Carbon dioxide is further react with the coke at 1000 degrees Celsius, return to carbon monoxide. So for this reaction, heat energy is absorbed from the blast furnace. Heat energy is absorbed because see 1500 degree to 1000 degrees reduces, heat is absorbed for the reaction. So the minus heat, it is given see in the reaction minus heat. Minus heat means heat is absorbed. Heat is absorbed. So this is endothermic reaction. Also see one more reaction also take place, limestone. Limestone is nothing but it is a calcium carbonate, CaCO3 is called limestone. On heating, because of the temperature 1000 degrees Celsius, this is going to decompose. Decompose means split. Calcium carbonate split into calcium oxide and carbon dioxide. So in the equation it is given carbon dioxide alone, but you have to include CaCO3 gives CaO. You have to write CaO plus CO2. CO2 is there. Calcium carbonate gives CaO, that is calcium oxide plus carbon dioxide. So minus heat represent, that is the type of endothermic reaction. So these two are endothermic reaction. That means absorption of heat during the chemical reaction. So this calcium oxide CaO further react with the silicon dioxide SiO2 and turn to calcium silicate CaSO3, that is removed in the form of slag impurity, the fused impurity formed during the chemical reaction. The fused impurity formed during the chemical reaction, which is called slag. This slag is removed through the bottom hole given like a slag outlet in the blast furnace. So in the middle region, you have to understand temperature is 1000 degree. Here reduction take place. Carbon dioxide is reduced to carbon monoxide. Then calcium carbonate is decomposed into calcium oxide and carbon dioxide. And next one, calcium oxide further combined with the silicon dioxide, silica, and calcium silicate is removed in the form of slag. So this is in the second region, that is a middle region. Then the third one, that is called the upper region. The upper region is nothing but called reduction zone. Reduction. So reduction, that is the process of removing oxygen from the substance. Removing oxygen. So the temperature prevails 400 degree. Here the temperature is 400 degree only. In this region, carbon monoxide reduces ferric oxide to iron. Carbon monoxide reduces ferric oxide to iron, that is Fe2O3, that is ferric oxide. This is going to react with the carbon monoxide, 3 moles of carbon monoxide. Whatever, see this carbon monoxide going to absorb, going to taken out the oxygen from this ferric oxide. So Fe2O3 turned to Fe, removal of oxygen. Fe2O3 to Fe, that is removal of oxygen, that is called reduction. At the same time, carbon monoxide turned to carbon dioxide in the product. 3CO into 3CO2. 3CO into 3CO2, that is oxidation, because oxygen is added to carbon monoxide. So carbon dioxide is formed, this is oxidation. So both the reaction take place in this process. See, Fe2O3 is reduced to Fe, carbon monoxide is oxidized into carbon dioxide. So here carbon monoxide only reduces ferric oxide to iron. And next one, see, the molten iron is collected at the bottom of the furnace, removing the slag. The iron thus formed is called pig iron. Pig iron means more or less it is not a completely pure form of iron, it is an impure form of iron. So it's going to be remelted, and after remelting it is going to be cast into different molds. Depends upon the requirement, different molds are used to cast the iron. So it is called cast iron. So my dear students, you have to know what are the steps involved in this extraction. In the extraction we use that, see, first one, see, iron is a second most abundant metal. It is obtained in the form of oxide, sulfide and carbonate. Hematite Fe2O3 is G4, and it is concentrated by gravity separation. So light impurities are washed away, heavier ore particles are settled down. Then during the calcination, the impurities like sulfur, arsenic, phosphorus are oxidized off. Then in the smelting blast furnace, it is charged by the roasted ore, coke and limestone in the ratio of 8:4:1. And there are three important regions in the blast furnace. Lower region, which is called the combustion zone, temperature is 1500 degrees Celsius, and here the coke burn with oxygen to form carbon dioxide. So during this reaction, heat energy is liberated out, so it is exothermic reaction. The middle region, also called fusion zone, here temperature is 1000 degrees Celsius. Here carbon dioxide is reduced to carbon monoxide and heat energy is absorbed for the reaction. So this is endothermic reaction. Also calcium carbonate decomposed into calcium oxide and carbon dioxide by absorbing heat, endothermic reaction. Then this calcium oxide further combined with the silicon dioxide to form calcium silicate, which is slag removed through the slag outlet. Then next one, see, there is upper region reduction zone, temperature is 400 degrees Celsius. Here reduction take place, that is the Fe2O3 ferric oxide is reduced to iron in presence of carbon monoxide, and the iron formed is called pig iron, and it is further remelted and cast into moles, so it is called a cast iron. Then physical properties, it is a lustrous metal, grayish white in color, and high tensile, malleable and ductility. It can be converted into thin wire, and it can be hammered into very fine thin sheet. So it will not easily break. Then it can be magnetized using some methods. Then in the chemical properties, reaction with the air or oxygen, only on heating in air, iron form magnetic oxide. So normally it will not going to form the magnetic oxide Fe3O4 in presence of temperature the iron react with oxygen, a black color magnetic oxide Fe3O4 is formed. Then reacts with the moisture. This is an important reaction. The second reaction, that is reaction with the moisture. Normally see, when the iron is exposed to moisture, suppose the iron is in the moisture, or normally the iron is in the outside, and when the ions are in the ground, what happens is after some days or some week, you would have seen that a brownish color layer is formed on the surface of iron. That is nothing but that is called rust. Rust. What is the name of rust? The chemical name, that is hydrated ferric oxide. Hydrated ferric oxide. That is the chemical name of rust. So the phenomenon, the process of formation of rust is known as rusting. The phenomenon of formation of rust is known as rusting. The chemical reaction is given 4 moles of iron with 3 moles of oxygen with the X H2O, depends upon the moisture present in the air or in the ground. So it turned to 2Fe2O3 and XH2O. So that Fe2O3 XH2O is the formula of rust. That is only called hydrated ferric oxide. Hydrated ferric oxide. So this is important reaction. Will be asked what is rust, and how rust is formed. This is the chemical reaction. So what are the elements required for the formation of rust? There are two main elements, for example oxygen and water. Also one more element, that is carbon dioxide, also one of the element for the formation of rust. So oxygen, water, carbon dioxide, these are the three important elements for the formation of rust. Then next one, reaction with the steam. When steam is passed over red hot iron, magnetic oxide steam, already in the first reaction that I have seen, when it is heated, it form magnetic oxide. Also when we allowed to react with the steam, that is steam means that vapor with the high heat, water vapor with high heat. So 3 Fe plus 4 H2O, that is steam. Then magnetic oxide is formed by the liberation of hydrogen. Also metals normally react with halogens to form metallic chloride. Similarly here, iron is react with chlorine. Iron react with chlorine to form ferric chloride, FeCl3, ferric chloride. Then with the acids, dilute acids like HCl and sulfuric acid react with iron to form concerned salt. Hydrochloric acid will give, that is ferric chloride, ferrous chloride, and iron with sulfuric acid, ferrous sulfate. FeSO4 is ferrous sulfate. Also see, dilute HNO3 in cold condition. In cold condition react. Iron react with 10 moles of nitric acid, 10 HNO3 to give, that is FeNO3 twice. FeNO3 nitrate of iron and ammonium nitrate, also water. These things will be formed when iron react with the dilute HNO3. Then in the next one, also iron react with the concentrated sulfuric acid, give ferric sulfate. Iron with 6 moles of sulfuric acid, iron ferric sulfate, FeTSO4, that is ferric sulfate and sulfur dioxide, water are formed. Then the next one is given, that is important, will be asked. Normally when iron dipped in concentrated nitric acid, it becomes chemically passive or inert. Give reason. The question will be asked, when iron is dipped in concentrated HNO3, it becomes chemically passive or inert. Give reason. So the reason is given here itself, due to the formation of a layer of iron oxide on its surface. So iron will not easily react with the concentrated HNO3, but it will react to dilute nitric acid. Dilute nitric acid give that is a nitrate and ammonium nitrate, but concentrated nitric acid will not have any reaction with the iron because of the formation of a layer of iron oxide Fe3O4 on its surface. Then uses of iron. The iron is going to be classified into three types. Iron is classified into three types based on the carbon content. How iron is going to be classified, the first quality, second quality, all these, and how it is going to be differentiated based on the requirement, only the composition of carbon content in the iron. So for there are three types: pig iron, steel, wrought iron. Pig iron, steel, wrought iron. Pig iron consists, that is 2 to 4.5 percentage of carbon. In pig iron, 2 to 4.5 percentage of carbon. In steel, less than 0.25 percentage of carbon. In steel, less than 0.25 percentage of carbon. Wrought iron, 0.25 to 2 percentage of carbon. 0.25 to 2 percentage of carbon. Then what are the use of pig iron? It is used in making pipes, stove, radiators, railing, and manhole covers in the train pipes. And so these are the uses. The hard materials, heavy objects can be prepared using this type of pig iron. Then steel. This is mainly used in the construction of building, machine parts, and transmission cable, TV towers, and alloys can be prepared using steel. Then wrought iron, having the carbon content 0.25 to 2 percentage, it is used to making springs, anchors, electromagnet. These things can be manufactured, prepared using wrought iron. So these are the uses of few uses of iron based on their carbon content. So my dear students, you have to go through up to this what under all we revised now. That is mainly in the extraction of iron. Extraction of iron. Uh, you have to revise, that is the important ore is hematite Fe2O3, concentrated by gravity separation, roasting and calcination, then smelting in blast furnace. uh, uh, the ratio of charge is 8:4:1. Ore, coke, and limestone. There are three regions in the blast furnace: lower region, middle region, and there is upper region, that is the reduction zone. And chemical properties with oxygen, with moisture. So second property is the important one. Then also the uses of iron based on the types: pig iron, steel iron, wrought iron. So you have to revise all this, and questions will be asked: how will you extract iron from the ore, and what is rust, and write the chemical reaction for the formation of rust, and what is the reaction between iron with steam. And also, when iron is dipped in concentrated HNO3, it becomes chemically passive or inert. Give reason. And also uses of iron. So you have to go through, and the equations you have to write and practice in your separate rough notebook. Equations will come only by practice. How you are practicing to solve the problem in maths. Similarly, you have to practice. Only regular practice will enhance to write the equation fluently. So don't waste time. You can write in classwork, in separate classwork, or in the same classwork, same notebook. From one side you can write physics, from the other side you start to write chemistry. That depends upon that you are going to use for your practice, for your learning purpose. So don't waste the time. Daily you have to study, because you have enough time at home. You have free time at home. There is no fixed timetable is given to you. At any time you can sit and you can prepare, write and practice, learn thoroughly. So now you are very very free. Enough time is given, so don't waste the time. Prepare well, get the knowledge of all these learned lessons. Till that, be safe at home, and thank you. God bless you.